most of those monolithic applications do not handle change well. And because of that, we tend to see less rotation and less of a focus on security at the application level.
Hi, you're listening to The Secure Developer. It's part of the My DevSecOps community, a platform for developers, operators, and security people to share their views and practices on DevSecOps, Dev and Sec collaboration, cloud security, and more. Check out mydevsecops.io to join the community and find other great resources. This podcast is sponsored by Snyk. Snyk is a dev-first security company helping companies fix vulnerabilities in open source components and containers without slowing down development. To learn more, visit snyk.io. On today's episode, Guy Podjarny, president and co-founder of Snyk, talks to Seth Vargo at DevSecCon Seattle. Seth previously worked at HashiCorp, Chef Software, Custom Inc., and a few Pittsburgh-based startups. He is the author of Learning Chef and is passionate about reducing inequality in technology. He is now a developer advocate at Google.
Hello, everyone. Welcome back to The Secure Developer. Today we have another DevSecCon edition version of it, and we have with us Seth Vargo from Google. Thanks for joining us, Seth.
Cool. Thanks, Guy. Thanks for having me on the show. I'm really excited to be here and talk a little bit about secrets.
Oh, secrets. Talking about secrets is always best. So before we talk about secrets, first secret, what is it that you do?
Well, if I tell you, I have to kill you. No, so I work for Google. I work on the developer relations team at Google. My day is spent in a triad of things. So I'm out with communities. That's why I'm here at DevSecCon Seattle, meeting with users, figuring out what security challenges they're having. And then I'm also coming and kind of taking that feedback, synthesizing it. I like to say I translate customer into engineer. Then I take that back and work with our product and engineering teams to make sure that our products are meeting the needs of what the communities are telling me they want out of, security products or just products in general.
Yeah. Hence the sort of, I guess that's sort of the relation part of that sort of advocacy.
Yeah.
Kind of
I'm like Google Translate as a service, right?
That's a good way to sort of think of it. So, you deal in general when you talk about advocacy, like what space of developer relations do you deal with?
Sure. So when I first joined Google, I did a lot of stuff in the DevOps and site reliability engineering space, but security's kind of always been a passion of mine. And more recently, especially with my background working at HashiCorp, the company that makes Vault, I have transitioned into this role where I do a lot of focus on security, but I'm more focused on how we can make security everyone's responsibility and less so like what kernel vulnerabilities exist in like this release of this thing, right? So it's we have advocates who are focused on security. I'm more focused on like the human element of security.
Of kind of, helping people be secure as they evolve. So I guess that's a good segue to your talk. So what is your talk going to be about at this event?
Yeah, so there's obviously this new thing. I don't know if you've heard of it. It's where you use other people's servers and you pretend they don't exist.
It's called the cloud, no?
No, that's called serverless. I guess that's true too. It's like serverless, right? It's this idea of, there's computers out there somewhere, but here's my code. Either it's in a container or it's in some packaging format. Please run it for me and scale it infinitely, air quotes, for those listening at home, right? And that movement was started by developers, and there wasn't a lot of focus on security, right? It was all about, I'm going to bypass my operations team. That's why we're doing serverless. We don't have to worry about acquiring compute, networking, and storage. And I'm going to bypass my security team because, it's just serverless. Like someone's doing everything for me. We see, I have my serverless application. Maybe it's something that is doing social media monitoring and it needs a Twitter API key and a Facebook API key in order to, get metrics or data from those third-party systems. Or maybe it's sending a text message. So we need like a Twilio API key. And how do we get those secrets or those credentials into these serverless applications? How do we do TLS? And really shifting the responsibility left, because developers are like, we don't want security in our cycle, and now they're deploying insecure applications. So it's fine if you don't want security in your, your release cycle, your CI/CD process, but you still need to care about security, and we have to shift that as left as much as possible. Yeah,
you can basically you can try and remove the security team from your process, but the security bit, that kind of has to stick around, or you might be in bad shape.
Yeah, so my talk is really a journey. It's more of a story, a fake story, but a story of how we took this application, we deployed it, we put all our secrets in environment variables, and then we got pwned and we showed up on the front page of Hacker News and everyone was like, well, how on earth did we get hacked? And, first it starts out that we didn't run our application in production mode, and therefore whenever someone caused our application to crash, the entire environment was dumped because that's what our web framework happens to do. And this is really common, right? Django, Rails, if you're not running in production mode, whenever that application crashes, it tries to be helpful and it prints out the entire environment. All our secrets were in there. So we patch that, we deploy in production mode, we successfully get, a generic 500 error. But then it turns out that there's a malicious dependency in our software supply chain, actually. And even though we've, mitigated this one particular part of the attack, it turns out that on boot, there's this package that otherwise is helpful in our dependency chain that is just running the env process and then posting it to a random pastebin endpoint. So an attacker is basically getting a full dump of our environment.
Yeah.
And as a result, we haven't really increased our security much. And this is actually very common, especially in the Node.js community. There's been a lot of attacks on like Bitcoin wallets, et cetera, where there's an otherwise useful package that has, a little bit of code in there that every so often does something very nefarious.
Yeah, it's been unfortunately kind of growing substantially. Well, either the symptom of malicious libraries has been growing or our ability to detect them has been growing. Either way, there's definitely kind of more incidents of this.
Yeah, so we talk a little bit more about like automated vulnerability scanning and could we detect this? And the unfortunate part is like, yes, we may be able to detect this, but someone has to report it first, right? This is one of the challenges with a lot of, the vulnerability scanning is like they're really great for detecting things that have already happened. So we move into the next logical step, which is like, okay, well, if we're going to use environment variables, we can't store our secrets in plain text in those environment variables. So we have to look to some type of encryption. So what if we encrypt them using like a key management service or some encryption software that is a third-party piece of software, and then at boot, our application decrypts those environment variables and only stores the plain text values in memory, right? So if an attacker runs the env command or dumps out the environment, they just see encrypted bits of data. And if an attacker were to, say, trigger a core dump, or if they were doing a targeted attack where they knew that you were using a key management service, they would still be able to get access to those secrets.
But it still raises the bar. Like it still makes it harder or potentially kind of moves you off the scripted, like the generic ones, and veer more into more sophisticated or more targeted version of attack to get that data.
Right. And this brings up a really interesting point that I'm trying to get people to think about, which is that security is not binary, right? Yeah. People, especially developers, often think of security as like a light switch, which is like, oh, I'm secure now or I'm insecure, but it's really a spectrum and it's constantly evolving, right? And the type of security that an application needs varies, right? A payment processing system needs significantly more security than, say, like a static HTML website that's running, on an Apache server and has no access to anything else. And this is where you have to kind of make a threat model and assess, like, how much effort do we want to put into this to actually consider ourselves secure, right? And what is our threat model? And are we socializing that with our internal teams as well? If we have stakeholders or teams that are depending on our service, what is our threat model? What security guarantees do we make? And specifically, which ones do we not make?
Yeah, for sure. But, you left me kind of in suspense. So, like, you're in that spot, you can do the core dump. Is that where the story ends, or is there another chapter?
No. So the last thing we then look at is, how do we prevent an offline attack? So if an attacker is able to get access to that running instance, they can trigger a core dump. Like, that's a really targeted attack. There's a number of ways we can protect against that, but those all involve like using things like memory locking, auditing your dependency trees. But ultimately, the way that you best protect against leaking secrets is just to assume that they're going to be leaked. The best protection is assuming that you have none. And this is where you bring in like a secrets management solution, something like Vault, where instead of hard coding a credential that sits in an environment variable, maybe you need a password to talk to Redis, for example. Instead of that being, a hard thing that sits in a string in an environment variable, whether it's encrypted or not, you instead acquire that credential at runtime, and it only lives for the duration of the process. Especially in serverless, these applications generally aren't very long-lived. They're, spin up a microservice, do some processing, listen to a pub sub event, and then turn down. So instead of having a shared credential, we instead, at boot, authenticate to some service like Vault. We get a single use or maybe a time-based credential that expires at the end of that function. So we're limiting the scope that an attacker can have access by limiting the time the credential is valid. And when the application dies or when the serverless application, terminates, we revoke that credential automatically.
So this is kind of panacea, I guess, kind of, if you have this sort of automated key management systems. How often do you see it in the wild? I mean, when you look at you see from the Google side, people using Google Cloud, or from the experience with Vault, which I guess might have a bit of a selection bias as is that user base. I find when I talk to people, there's a general appreciation to the KMS side, but key rotation and this notion of like actually expiring that key, maybe not as well adopted. Is that a fair statement?
I think it depends on the organization. I think this is a really good question. It depends on who is responsible for managing the key management service. If it's a security team and the developers just know that there's an API that they call to do encryption for them, the security team is likely rotating those keys frequently. They may be rotating them every 30 days or, even every 2 weeks. And to developers, every key management API is like encrypt this piece of data and it automatically uses the most recent key. If the developers are controlling those keys, on the other hand, especially if they're not super security conscious, it might not be as regular. There might be like a Jira ticket that's in the backlog somewhere that's like, go rotate that key. Yeah. And this is why, like specifically on Google, we actually have automated rotation for our keys. So you can set up, basically, I like to consider it like a cron job that sits within KMS that's like, rotate this key every 90 days. And it'll just automatically rotate it. And then that brings up the other side of it, which is you have all this old data that's encrypted with kind of an older version of a key. How do you upgrade it? And this is where the other side of security that we don't do a lot of talking about comes in, which is auditing and logging and reporting on that data. Even with all of the protections we put in place in the talk that I'm giving, there's still a security vector, right? There's still a threat model where an attacker could gain access for a very short period of time. Yep. And the only way that we can really deal with that moving forward is to detect it and respond to it appropriately. And that's where, auditing and logging and more recently anomaly detection is coming in, which is, especially if you work in a larger company that has a lot of data, feeding that into a system that analyzes when secrets are being accessed, from which applications and services they're being accessed. And whenever something doesn't look right, firing an alert and saying, hey, this doesn't feel appropriate. Someone should take a look at this. The same way that, a big spike in memory usage might flag someone on the site reliability engineering team. We do the same for the security team.
So I think definitely, need to kind of, track them. And I guess, back to your point about security not being binary, right? You've still reduced the attack possibilities, right? So the attack surface or the likelihood of a compromise. How much is this serverless? Like, you use serverless as your example, right? And use KMS, in this storyline, you should write a book about it. How much of this is different, is serverless specific or is different in serverless versus, a containerized environment?
So I think in a containerized environment, it's pretty similar. I'll rephrase your question so I can give you a different answer, which is, what about like traditional VMs and like on-premise infrastructure? When we think of like traditional applications, especially monoliths, right? They tend to be like spun up and then they live forever. Yep. So the key difference is that a serverless world and even a containerized world, applications tend to be a lot more ephemeral, right? They come and go, they get moved around, they get rescheduled, especially if we're using like Kubernetes or Nomad or Mesos or Aurora, whatever it might be. In an on-premise world, most of those monolithic applications do not handle change well, whether that's a configuration change or whether that's a secret change. And because of that, we tend to see less rotation and less of a focus on security at the application level. And instead, organizations put that thing in a box, put a firewall around it, use networking policy to try to restrict access as much as possible. And sometimes there's a cultural aspect here as well, which is that application was written by a developer who left the company 20 years ago. It's running on Java 3.5 and like no one is going to touch that thing. We need it to keep running for now, right? And that's really the key difference is like a lot of the paradigms that I'm pushing for don't work well with those very legacy, very non-cloud native applications. Rotate secrets frequently. That means your application needs to handle graceful restarts. That's a cloud native property or a 12-factor app property. That's not a property that legacy applications may exhibit, and that makes it really difficult to follow some of these best practices.
Got it. Yeah. I guess in concept, you could do it, in a VM, but just means it wouldn't be as natural, in serverless or in sort of short-lived containerized environment. It's just elegant in the sense that you get the key, and throughout the life of the invocation, the key is just that key.
Yeah.
How does this relate? So in serverless, there's, one of the, oftentimes the myths is this thought that you get a system spun up for every serverless call. When you use a KMS or those environments in the serverless environment, does the key stay, in memory for the duration of the instance's existence or the function's invocation, if that makes sense?
It stays...
If an instance stays warm.
Yeah, so it stays in memory for the lifetime of what we call the cold boot. So the first time you hit a serverless function, there may be no running instance. So you eat what's called cold boot time, which is spinning up of, say, the container or the VM or whatever, depending on the cloud provider. And then the initial init functions that code runs. So in Go, there's like an init function, right? Node.js, anything that's outside of a main function will execute before the function can respond. That's cold boot. And then from that point, the instance is available. And as long as it's continuing to get requests, it will stay hot, as we call it, right? Opposite of cold boot. And during that time, your secrets, your keys, whatever, will live in memory of the instance. But then when the instance terminates, it doesn't get a request for a certain period of time. Or if you've set some timeout for the maximum lifetime, at that point, the instance is killed. I can, on Google specifically and Cloud Run, which is our serverless offering, it's actually built on top of the Knative open source tool. So it is just a container. So the same kind of expectations you'd have around starting a container, you have with Cloud Run as well. So you can set things like CPU and memory availability, maximum timeouts, concurrency, that type of stuff.
Got it. Yeah, and I guess, and my next question would have been, but you actually kind of answered it, but the performance impact of using a KMS, but at the end of the day, it probably just gets absorbed into that boot time, cold boot startup time.
Yeah, you could, this gets into a little bit of an architecture discussion, but you could architect your application so that every HTTP call invokes KMS to decrypt the secret to fulfill the user's request. That's going to incur a lot of extra latency in the request cycle and also potentially extra costs as you're going to hit the KMS service with every user request that you get. A more scalable approach is at cold boot, once you're going to call the KMS service, decrypt the keys or decrypt the secrets and store them in memory. And then moving forward, every request is a little bit, faster. And then each of those have trade-offs, right? There is no right or wrong answer. It really depends on your threat model. And this goes back to threat modeling is super important when building these applications.
Got it. So what's maybe just one last question, we're sort of going a little long here. Is there another sort of step in the sort of the secrets management horizon? Is there something past, key rotations and KMSs that is even better, that is sort of around the corner?
Yeah, I hinted at it earlier. I think ephemeral, short-lived secrets or just identity and access management in general is the right direction. Having a credential that is only valid for the lifetime of my function and can only access these one or two things, right? Principle of least privilege. The second thing is do you even need a secret in the first place? If you're using a cloud provider or even multiple cloud providers, can you leverage OIDC and cloud providers' identity and access management to do PAM? So there is no exchange of a credential. This function or this serverless application is able to talk to this SQL database because I set up a permission at the cloud provider layer that enabled that to happen. And then there is no exchange of credential. There actually isn't a vector for an attacker to try to escalate some privilege because that lives at a higher level than the application or service that you're talking to.
Yeah, got it. Makes sense. And I guess you can open up a different conversation about all your eggs in one basket around this access management portals. But I think that's a topic for its own podcast or 10 of them, on those. Seth, this has been fascinating. I definitely encourage people to go watch the YouTube video and sort of, see the whole story unfolds. We got the good kind of cliff notes over here. Thanks for coming on the show.
Yeah, thank you for having me.
And thanks everybody for tuning in. I hope you join us for the next one.
Thanks for listening to The Secure Developer. That's all we have time for today. For additional episodes and full transcriptions, visit mydevsecops.io. If you'd like to be a guest on the show or get involved in the community, you can also find us on Twitter at @mydevsecops. Don't forget to leave us a review on iTunes if you enjoyed today's episode. Bye for now.